Dear students, in the previous class we have discussed about the how to write the rational and irrational numbers by using the decimal expansions. How to write the rational and irrational numbers by seeing their decimal expansion of the given t by q for numbers. So now today we shall see how to classify the rational and irrational numbers, and also we will see the simple problems on the expressing the irrational numbers to the t by q forms. So shall we recall the previous class? In the previous class we have seen the decimal, by seeing the decimal expansions, the rational numbers. A rational number means a number whose decimal expansion is terminating or non-terminating recurring. So if a decimal expansion has terminating or non-terminating recurring, so they are called as rational numbers. So whereas coming to the irrational numbers, a number whose decimal expansion is non-terminating and non-recurring, so it is called as an irrational number. So here we will see the problem on the exercise. So 1.3, exercise 1.3. So in that ninth part is there, ninth question is there. Ninth question, classify the following. Classify the following numbers as rational or irrational. Rational or irrational. First one is root 23. Second one is root of 225. Square root of 225. Third one is 0.3796. Fourth one is 7.478. Etc. Fifth one is 1.10. 100. Students, observe this map. So in this map we have to classify the given numbers as rational and irrational. So by the definition, so here is that rational number means a number whose decimal expansion is terminating or non-terminating is recurring. So first, if you observe the numbers, so first one is root 23, second one is square root of 225. third one is 0.3796, fourth one is 7.478478, etc. So fifth problem is 1.1011001001. So if you observe this problem by the definition, so if we take one by one, or we can simplify, we can separate or classify first rational, next irrational. So on that way we can simplify, or we can take so one by one. So if you observe first one root 23. So it is not a perfect square number. So if you divide this, you will get the numbers, decimal numbers, as non-terminating. So therefore, this is an irrational number. This is an irrational number. Whereas coming to the second one, root of 225, or square root of 225. So it is a perfect square number. This can be written as 15 square, because 15, if you multiply 15 15s up, you will get 225. So the simplified form is 50, which is of the form p by q. Therefore, it is a rational number. It is a rational number. It's a rational number. So if we come to the third problem, so 0.3796. So this is a non-terminating recurring decimal. So this can be expressed in the form of p by q. Therefore, this is also a rational number. It is also a rational number. So we can write it in the form of p by q. So if we come into the next fourth one, so fourth problem, it is also written in the form of p by q. We will see in the next next method, expression of decimal numbers to be p by q form. So therefore, fourth one is 7.478478, etc. So this is also, this can also be written in the form of p by q. So therefore, it is also a rational number. It is also a rational number. So coming to the fifth one. Fifth one is 1.1010101401x, which is, so this cannot be expressed in the form of p by q. Therefore, is an irrational number. This is an irrational number. Is an irrational number. Okay, students. Now, students, we will see the next main exercise 1.3. 1.3 is express the following. In the form of P by Q, where P and Q are integers. P and Q are integers and Q is not equal to 0. So this is the main we are going to simplify. So in this main, we have to express the given decimal numbers into P by Q form. First one is 0.64. 0.64. So in this main we have to convert. So this decimal expansion into a rational number or P by Q form. So now we shall see the steps. So solution for this is, students, now first we have to put, so this 0.64 as x, let x equals 0.64. So call this equation, this can be written as x equals 0.666. You can write it like this also. Call this as an equation number 1. So in the next step, here after the decimal point, so there is one number is there. So after the decimal point, there is one number is there which is repeating. So we have to multiply. So therefore we have to multiply this equation by 10. Why here we are going to multiply this by 10 only? Because after the decimal point there is only one digit number is there. So multiply this by 10 on the both sides of LHS and RHS. We will get 10 into x equals 10 into 0.666, etc. So it will become 10x equals, so this will become 6.666, etc. Call this as an equation number 2. So now subtract equation number 1 from 2. Now subtract equation 1 from 2. So we will get in the LHS side 10x minus x equals, so in the RHS side 6.666, etc. minus 0.666 etc. So if you subtract this, you will get 10x minus x is 9x. It will becomes, if you subtract 6.6666 etc. 0.666, you will get 000. Here it is 6. That means you will get 6. So 9x equals 6. So this will become x equals 6 by 9. Or if you simplify, the simplified form is 3 2s are 3 3s. So therefore x equals 6 by 9 or 2 by 3. X equals 6 by 9 or 2 by 3. So which is of the form p by q? Which is of the form p by q? Which is of the form p by q? So therefore the p by q form of 0.6 or is 6 by 9 or simplified form is 2 by. Now students, we will see the another problem. Second problem is 0.47 bar. So that means here 7 is repeating. Let us take that x equals 0.47 bar. So multiply this equation by 10. We will get 10x in the left side. So this will becomes in the right side. So this will becomes 4.7 bar. Or we can write it as 10x equals 4.777 etc. So call this as equation number 1. After that, so by equation 0.47, so it should be multiplied by 100. Now x equals 0.4777 etc. If this is multiplied by 100, it will become 100x. In the left side, it becomes 100x equals, to the right side, 100 into 0.4777, it will become 47.777 etc. So call this as an equation number 2. Call that as an equation number 2. So now subtract so equation number 1 from 2 we will get in the left hand side 100x minus 10x 100x minus 10x equals, to the right hand side students, so here in the equation number 2 47.777 etc. minus, so equation number 1 is 4.777 etc. So if you simplify the left side, so 100x minus 10x, so it will become 90x equals, if you subtract 47.777, etc. Subtract 4.7, 4.777, etc. We get 77000. Here 7 minus 4 is 3, and it is 4. So we get 43.00 or 43. So 90x equals 43. So it can be written as x equals 43 by 90, so which is of the form p by q. So which is of the form p by q. Therefore, it is a rational number which is of the form p by q. So therefore, this decimal is also written in the form of p by q, or it is expressed as a rational number. Students, now we shall see the next problem, that is third problem. Third problem is 0.001 bar. 0.001 bar. So in the similar way, what we have done in the previous problems, let us take solution for this is, let us take x equals 0.001 bar. So here, after the decimal point, there are 3 digits are there. So therefore, call this as an equation number 1 and multiply this equation number. Students, now we shall see the operation on the real numbers. That means the fundamental operations: addition, subtraction, multiplication, and division. So to do these problems, so we have to keep some points. We have to remember some of the points, so which can be examined by taking an examples. So first point is the sum or difference of a rational number. The sum or the difference of a rational number and an irrational number is rational. So that means if we add or subtract both the rational and irrational numbers, we will get the irrational numbers. So second point is the product or quotient. So product or quotient means if we multiply or divide quotient of a non-zero rational number with a irrational number. Rational number with irrational number is an irrational number. Product and quotient is irrational number. So third one is if we add, subtract, multiply or divide two irrational numbers. So if we add that means in the fundamental operations both are irrational numbers. So we will get the result will be either it may be the rational or it may be the irrational. So whereas in case of the sum and difference of, so here in this point you have to remember that the sum and difference of the rational and irrational. So rational part and so if it contains a rational and irrational number, if we add or subtract, we will get an irrational number. So in the second point, so the product and the quotient. So if you multiply or if you divide a rational number with an irrational number, the result will be the irrational number. So whereas in case of both are irrational number, if you add, subtract, multiply or divide, you will get either it may be the rational or it may be the irrational. Now we shall see the problem. Exercise 1.5. Exercise 1.5. 1.5. So in this exercise, we have to first main is there. First main. Classify the following numbers. Following numbers as rational or irrational. So here in this program we have to classify or we have to write whether it is a rational number or it is an irrational number. First problem is that 2 minus root 5. 2 minus root 5. Students, observe this problem. So it contains this problem 2 minus root 5. It contains both rational part and irrational part. So 2 is a rational number whereas root 5 is an irrational number. So if you observe the point number 1, the sum or difference of rational and an irrational number. So here it is the 2 is a rational number and root 5 is an irrational number. So here we are going to subtract. That means we are going to take the difference. So difference of rational and irrational number. The result will be less than irrational. So therefore, 2 minus root 5. The result will be, the answer will be irrational. So to simplify this, you have to subtract the value of root 5. So the value of root 5 is obtained by dividing 5, which is you are already studied in the 8th standard. So try that. So here in this problem we have to classify whether it is a rational or irrational. So therefore I have write directly it is an irrational number on the point number 1. So if you want to clear it, so you can subtract. So the value of 2 5. So it means 2 2s are 4. 5 minus 4 is 1. Add 2 2. This 2 2 it will become 4. So next put a point. We get zeros, 2 zeros. So if you divide like this, like that process, you will get a value of root 5. So the value of root 5. So 2 minus root 5, it is an irrational number. So in the second problem is 3 plus root 23. 3 plus root 23 minus root 23. So observe this problem. 3 plus root 23 minus root 23. So simplify. So remove the bracket. 3 plus root 23 minus root 23. So here it is plus root 23, it is minus root 23 get cancelled. So we will get the answer is 3, which is a rational number. Therefore, So this is a rational number. It is a rational number. It is a rational number. Friends, now we shall see the next problem. Next problem is third one is 2 root 7 by 7 root 7. 2 root 7 by 7 root 7. So the solution for this is write 2 root 7 by 7 root 7. So here root 7 get cancels. The remaining is 2 by 7. So which is of the form p by q. Therefore, it is a rational number. It is a rational number. It is a rational number. Now we will see the next problem. The next problem is fourth one is 1 by root 2. 1 by root 2. So if you observe that the numerator is a rational number, whereas in case of denominator it is a irrational number. So coming to the if you observe this and by observing this key points, so this will become, it is an irrational number. It is an irrational number. An irrational number. So next one, last one is fifth one. Fifth one is 2 pi. 2 pi. So here we have to say whether it is a rational or irrational. So in the previous class we have studied pi is an irrational number. Pi is an irrational number. So the product where 2 is a rational number. The product of rational and irrational is an irrational number. So therefore 2 pi is an irrational number. 2 pi is an irrational number. I think students, you have learned how to classify the given numbers as rational and irrational numbers. Students, now we shall see the second main of the exercise 1.5, simplify. First problem is 3 plus root 3 into 2 plus root 2. 3 plus root 3 into 2 plus root 2. So here we are going to multiply both the numbers. The solution is, first we will write the given problem 3 plus root 3 into 2 plus root 2. So So this type of multiplication you are already studied in the 8th standard, that is in the algebra. Multiplication of binomial by binomial. So we can write, we can multiply 3 plus root 2 from 2 plus root 2, or 2 plus root 2 from 3 plus root 3. So by using that knowledge, 8th standard knowledge, multiplication of binomial by binomial. So here we will write this as, so first I will write 3 plus root 3 as it is, 3 plus root 3. So this should be multiplied by first 2 plus is there. Once again write down first binomial, that is 3 plus root 3 as it is into root 2. Here 3 plus root 3 is written as it is, so it is multiplied by, separately multiplied by 2 and root 2. So in the next step, 3 plus root 3 write as it is, so multiply it by 2, write the symbol as it is, plus is there. So once again write down the 3 plus root 3 and next 3 plus root 2, multiply that. Or you can change it. So you can multiply this by 3 and 2. So now we shall simplify. So 3 2s are, it will become 6 plus 2 into root 3, so it is a rational, it is an irrational, it will become 2 root 3 plus, so now 3 into root 2 or root 2 into 3, so it will become 3 root 2, so plus into plus plus, so this will now root 2 into root 3, both are irrational, so it will become 3 2s are 6. 3 2s are 6. So therefore, the product of this is, so these are unlike terms. So these are unlike terms. So students, in this problem you have to remember the like terms and unlike terms of the algebra which you have studied in the 8th standard. So and also multiplication of, so monomial by monomial, monomial by binomial, or binomial by binomial. So the answer is 6 plus 2 root 3 plus 3 root 2 plus root 6. So this is the answer. So we will see the next problem. So the next problem is second one, 3 plus root 2 into, sorry, 3 plus root 3 into 3 minus root 3. So if you observe that problem, it is of the form, so that is a formula which you have studied in the algebra, a plus b into a minus b. If you write 3 plus root 3 into 3 minus root 3, so this is of the form a plus b into a minus b, a plus b into a minus b. So it will be written as a square minus b square. So if you compare the LHS, in place of a there is a 3 on the both the binomial. So therefore a equals 3. So if you observe, in place of b, here it is root 3. So here also in place of b it is root 3. So therefore b equals root 3. So substitute the value of a equals 3 and b equals root 3 in the right side. We will get, so 3 square minus root 3 whole square. So 3 square is 3 3s are 9 minus square and root get cancelled, 3, which will be equals 9 minus 3 is 6, which is a rational number. Students, in the similar way, you have to simplify the third problem. The third problem is root 5 minus root 2 into root 5 plus root 2. So this is also of the form a plus b into a minus b. So you can use that identity or formula. You will see the next problem. So fourth problem is root 5 plus root 2 whole square. So we have to simplify that problem. Root 5 plus root 2 whole square. So first we will write the problem. Root 5 plus root 2 whole square. So here in this problem we are going to use the identity or formula a plus b whole square. So the expansion of a plus b whole square is a square plus b square plus 2ab. So this is all which is already studied in the previous classes. So if you observe the left hand side of the formula and the problem, observe the left hand side of the formula and the problem, so you will get a equals root 5, a equals root 5, and in place of b it is root 2, b equals root 2. So now substitute the value of a equal to root 5 in the right side and the value of b as root 2 to the right side. So we will get a means root 5 whole square plus b means root 2 whole square plus 2 into a is the value of a is root 5 into the value of b is root 2. So now simplify. So 2 and root get cancels, which is already you have studied in the 8th standard. So it will become 5 plus similarly square and root get cancels, which will be the value is 2 plus 2 into root 5 into root 2 is, if you write it in the same root, 5 into 2 it becomes, so 5 plus 2, these two are the rational numbers, 7 plus 2 into 5 2s are 10. So the answer or the simplified form of root 5 plus root 2 whole square is 7 plus 2 root 10. Okay, students, I think you have understand how to simplify the problems. So we will see in the next class.